Hello there, thanks for joining me. Today we'll be assessing how I wrote an ancient Egypt game using C++ and its STL libraries, which are maps and vectors. So let's get right into it. First, let's take a look at the header files. I'm not gonna explain through all of them, but one that I would really like to share with you guys is this one, the algorithm. Basically, it's really useful for competitive programming if you are going with all those STL libraries. So a couple of perks if you use this header file are you get to do binary search. It immediately has a built-in function. It has all sorts of sorting and couple more other algorithms. I'll show you guys later down the video where I'm using this header file. Alright, so let's move on to the first thing that we need to do when you are making the board. So basically this is the design that I'm going for. As you can see, this is the pattern. That is, I have a plus symbol and then couple of minus symbols, and I don't know what we call that, line, vertical line. And yeah, I chose this pattern because it was appealing to me, and I felt quite comfortable. We now have to draw this board. So for that we have a function here and it's called showboard. So in showboard, what we are doing is there's this for loop. It is basically iterating through all those lines to draw the patterns. So the first function is calling the first line, which is draw board line 1. Then we are moving on to the next, calling the draw board line 2. So let's just check draw board line 1. What we are doing over here is it's a basic simple drawing pattern. So 2 for loops where we are printing our plus symbol, and then for an iteration of 3, because there are 3 minus symbols, negative symbols, we are printing the negative sign, and so on and so forth. And on the second line we are doing kind of the same thing, but here, as you can see, there's this a little bit of something out of character here, which I'll explain later what we are doing exactly here. But that's the basic gist of drawing the board. Now, after we have drawn the board, we need to initialize it. That's right. So for that purpose we are using maps. Now comes the meats and potato of this entire project. So maps are basically, let me just put up a description real quick. Alright, now that we are back, so what we are doing here is we have created a map and it takes an integer as key and a string as a value. So basically the number which is shown in to the players will be in the integer form, and there's this function called initialize board data where we are adding those filling in those numbers. So basically board data map dot insert, and this is how you fill in the keys and values, fill in the elements inside the map. So what this board number is basically an array of all those numbers but in string format. I need to explain to you guys about the enum that I'm using here. So it's basically not I don't know if it's suitable for this, but I just went with this one. Okay, I don't think this is the right way to do it. It's just how I did it. So enum here, game over states. So basically I have 4 enums: player win, draw, computer win, default. And then now that we have initialized our map data, we need user input. So in the main function we have call to our gameplay function, which is basically the whole whole structure. Like the gameplay is the gameplay where all the functions are getting called from. So in the gameplay, let me show you the gameplay function over here. So in the gameplay function we have first a call to initialize board data, of course, and then after we initialize the board data we show it to the player. Fair enough, so far so good. And then I have taken the user input and passed it to update board data. So update board data basically is getting the user input and filling in where the user has entered their input. So basically it checks. So okay, now let me explain you why I use the algorithm header file. So if you can see in this line 173, there is this function called find. Now you guys must be wondering, like, what is this find? There is no function or no object calling it, right? This is the pre-built function that our beloved algorithm library has. So what this does is it returns us whatever input, the third parameter that we pass, it returns us that input from a map. And if it doesn't find that value, it returns us the vector. It returns us the element from that vector. But if it doesn't find that vector, then it returns us the end element. So which is what I am doing over here. If I am finding and iterating through all those elements, if I find that particular element that I want to find, then it will return me the thing. But if it doesn't, then it will return me the end of the element in that vector. And if that's the case, then what I do is this. The iterator basically gives me the location of the element in the vector and the map. So here the map vector I have taken, and the second value, which is the string value, I take it and then in occupied box vector. Okay, so there are two vectors, which is occupied box vectors and available box vectors. So by how the name suggests, is basically doing those things. It's keeping hold of those values. And in occupied box vector, I push back the input because it has been filled. And this erase function of this particular vector, what it does is it releases the value from the available box vector. And then once that's done, I check. There's this function called check for game over. So this checks if the game is over or not. So let me go over that function really quick, and then we will return to this line. So check for game over. What this does is it basically, so this one was really tricky for me, but I somehow managed it to do it. I don't think it's the clean way to do it, but bear with me. So we have 3 iterators because obviously that's how we get the value from the maps, correct? Now the 3 iterators, this is taking for horizontally this is checking for vertically, and this one is checking for diagonally. So your 0 1 2, right? And it's gonna be 4 5 6, and then the third line 7 8 9. So that's how I take all these iterators, and then I pass it to this function which is called set current game state. So this function, what this does is it takes all those values and then it compares ki okay, first wala is equal to the second one, and then n also checks if first one is also equal to the third one, and if first one is also equal to the current player, then the condition is fulfilled and I set the current game state as player win, and vice versa. So that's how my check for game over is done, and the same thing for vertically, the same thing for diagonally. So basically it's 1 5 9 3 5 7, right? So back to that particular line. Once we have checked if the game is over or not, if it's not, we move on and it's turn for the computer. So basically there's this channel called Coding Train. I got like my starting inspiration from there for this particular project. There he has used arrays, 2D arrays, and solved this. So first time when he did the video, he used random generated positions for the opponent, for the CPU. But there is another video where he uses the min-max algorithm. I won't be going deep into that, but you can definitely check his video out. I'll link it down below. And so here I am not using min-max. It would have been way too much trouble for me, so I simply stayed with a random number. A random number is generated over here, and then basically here in this line what I'm doing is it's a random number is generated between it's from 1 to 9, because that's the size of the available box vector. And then I get a random number, and then I place a random value from the available box vector, release it from the available box vector, and then yeah, the computer's turn is over. After the computer's turn is over, let's get back. Okay, so here this was all done through update board data, correct? So once the update board data is done, computer check is done, we go to show board, and then your check for game over is once more called, because now we will have to check the input of our computer. And then what we do is we check the current game state and see what is the current state. If it's player win, we show player win, and so on and so forth, and we repeat. I'll leave a link to the source code. In the description. Let me know in the comments what you guys thought of using STL libraries for making Tic Tac Toe. And yeah, I'll see you on the next one. Hey, hope you guys enjoyed the video. Please remember to like, subscribe, and leave a comment. I also have a music channel. Link will be in description. It will mean a lot if you guys can support me there as well. Adios.